Welcome back. This is Joe Samo, your math hooligan. We're going to do a geometry crash course. I can't be too loud tonight because all the kids and wife are asleep. Geometry starts with a straight line. You have the straight line, and then you have points A, B, C, and D. And here, on a straight line, what you have to know is that line segment AB plus BC equals AC, for example, and we have BC plus CD would equal BD, and then we have AB plus BC plus CD equals the whole gamut, which is AD. Now, if we have something where we put numbers there, so we have 4, 2, and 6, those different line segments, to get AD, we would just add them all up to get 12. Then, let's say, another way they'll ask this is, let's say AB is x and BC is 2x and CD is 3x, and the whole thing from A to D is 24. I'm going to ask you a question. What is the distance from B to C? All right, what is line BC segment? I'll give you a second if you want to try that guy on your own, and then we'll do it together. All right, I hope you tried it on your own. The way to do this is you'd add x plus 2x plus 3x, and all that's going to equal 24. X plus 2x plus 3x is 6x, so 6x equals 24, x equals 4, and then we can punch it in there. So AB would be 4, BC would be 8, and CD would be 12. So what we wanted was BC, so that would be 8. Now, let's try another one. When we have a line segment, my favorite thing in terms of geometry teaching is we had a line, and now we have one more line, and they intersect. And when that happens, then we have 4 angles. Those are the 4 angles. A few rules that you have to know about these angles is the intersecting angles equal each other. So those 2 angles there equal each other, and those angles equal each other. Those are intersecting angles that equal each other. And then the 2 angles there on the top have to equal 180. The 2 angles together on the bottom have to equal 180. Anytime there's 2 angles on a line, they would equal 180. And all 4 of the angles equal 360. So a few ways they would ask questions about this. Let's say those angles there are 35 and 35. What is the other angle? You would just, we know that the 2 angles there on the bottom have to equal 180. So we would just subtract 180 from 35, and then that angle there would be 145. And then if that angle is 145, the other angle is equal, so both angles are then 145. Now, if we want to make sure, so 145, there's 2 angles that are 145, 2 angles that are 35. Let's add all of that up. It better be 360. Boom, 360. Okay, let's try another one. When we have one line and then we have an intersecting line, let's say that angle there is x, and that angle is 5x. And the question is, what is the angle over there? Try this on your own. I'll hit the pause button if you want to try this on your own, and then we'll do it together. I hope you tried it on your own. The way to do this is, if you look at the 2 top angles, x plus 5x, that better equal 180. So we can set it to 180, so that'd be 6x equals 180, and then x equals 30. And once we get x equals 30, we could just punch in 30 for x. 5x would be 5 times 30, so that'd be 150. And the angle that we did want is an intersecting angle, so it would be 150 also. All right, once again, I'm sorry I can't be too loud. Like I said, the kids are all asleep. Now, when we have parallel lines, meaning 2 lines that will never intersect because they're going on the same slope, and we have one line that intersects those 2 parallel lines, it's almost like a mirror image, those angles there. So those angles that intersect are equal, and then they're equal to the ones on the bottom. And then same thing with those angles, they're intersecting and they're equal. They, just imagine they're like mirror images of each other. That was a little redundant. Okay, so if that angle there is 135, and let's say for now we want to try to figure out the angle over there. The 135 would equal that angle over there, right? And then the intersecting angles are equal, so that angle on the bottom is 135. If we wanted to figure out that angle, we would just take the 2 angles together would be 180 minus 135. So we could take 180 minus 135, and that would be 180 minus 135 is 145. So that would be 45. Now we got triangles. We did one line, then we had 2 parallel lines. Now we enter the world of triangles. In every single triangle, All the angles have to equal 180 degrees. We have three sides. And then if we have those sides, we'll call them x, y, and z. The first rule I want to discuss is the sum of any two sides is greater than a third side. So meaning y plus z, those two sides have to be greater than x. And x plus y has to be greater than z. And conversely, which one did we leave out? Z plus x has to be greater than y. Okay, once again, the sum of any two sides is greater than a third side. Let's do a question together, see how you got it. Let's say x is 12, y equals 7. What is the range of z? Meaning, what's the lowest it could be? What's the longest it could be? Try it on your own. You can hit the pause button, then we'll do it together. I hope you tried it on your own. Okay, so let's calculate z. We could do it. What's the shortest? What's the longest it could be? I usually start with the shortest. It can't be 1 because then we'd have 7 plus 1 is 8, and that would not be bigger than x, which is 12. It can't be 2 because then we'd have 7 plus 2, and that would not be greater than 12. It can't be 3, because 7 plus 3 is 10. It can't be 4. 5 it could be, or it has to be a touch more, but because 7 plus 5 is 12. So y can be 7 and z could be just a touch over 5, and we can make a triangle work that way. Now let's see what's the longest that z can be. It can't be 20 because 20 would be greater than x plus y, which x plus y is 19. So z cannot be greater than 19. It has to be just a touch under 19. So the longest that z can be is 19. So then the range of z has to be, it has to be less than 19 and greater than 5. It can't be 40, it can't be 1, it can't be 102, it can't be 20. Okay? Let's keep moving along. Now the next order of business is all three angles must equal 180 degrees. And just for the heck of it, we'll try one. Okay, so I measured this with a protractor. That is 51 degrees, that angle. Let's measure this guy over here. That is 31 degrees. So one angle is 51 degrees, one angle is 31 degrees. Do it on your own. See if you could calculate that angle up there. You could hit the pause button if you want to try this. All right, I hope you tried it on your own. The way to, if you have two angles, we know that those two angles are 31 plus 51, that's 82. And all of the three angles have to equal 180. So if we take 180 and we subtract it by 82, 98. So that angle up top has to be 98 degrees. Now the next question is, what's the longest side? The rule is, in a triangle, I'll give you a second. Try this on your own real quick. What is the longest side of those three? I hope you tried it on your own. The rule is the side opposing the widest angle is the longest side. So here we have 98, and that opposes side x. So side x is the longest because it opposes the widest angle. What's the shortest side? The angle opposing the shortest side is the smallest side. Sorry, the side opposing the smallest angle. So here z opposes 31, and so therefore z is the shortest side because it opposes the smallest angle. Let's not leave out the middle child. The 51 is the middle, so therefore it would oppose the middle side. Okay, so remember this rule. The side opposing the widest angle is the longest side. The side opposing the smallest angle is the smallest side. Now let's do some more. All right, you got to practice these. Let's say here, you see that side is a very, very small side, the one on the top. And then if we draw the triangle a certain way, the angle that opposes that very small side, you see that that angle is very, very narrow. Why? Because you see that side. The side is very small, so the angle that opposes that side is very, very narrow. It's very small. Let's say we extended that side. Okay, so we make that side up top a lot higher. What happens to the angle that opposes it? The angle that opposes that side has to widen. Okay, so the longer that we made that side, see, we made it longer, so that the angle then had to be longer. You see that? Or the angle had to be wider, sorry. Again, sorry, I can't be too loud, my kids are asleep. And then just for the heck of it, let's say we extended that side even more. Okay, let me take this ruler, boom, boom, boom. All right, now we extend it way over there. What happens to the angle? The angle has to widen by a lot more. So the longer the side, the wider the angle that opposes it. So the angle that opposes the longest side is the widest angle. Now the next one is we're going to play name that triangle. This triangle here, if you notice, all those angles are lower than 90 degrees, so that's an acute triangle. An acute triangle is a triangle that has every angle that's smaller than 90 degrees. This triangle, if you see that the wide angle is 120, any triangle that has an angle that's bigger than 90 degrees is called an obtuse triangle. So acute is everything's under 90, and obtuse has one angle that's longer than 90. And then a right triangle is a triangle where there's one angle that's exactly 90 degrees. That is a right triangle. Other things, if we go back to this triangle, all the angles are different sizes, so it's called a scalene triangle. A scalene triangle just means every single angle is different. This triangle, you have two angles that are 30 degrees. This is called an isosceles triangle. An isosceles triangle has two angles the same size, which means two sides are the same size. An equilateral triangle means every single angle is equal. And because they're all equal, then every side would be equal too. That's an equilateral triangle. Now we're going to play a fun game. This is a nice vacation spot. If you ask me in the comments, I'll let you know where this vacation place is. It's really cool. I've never been there, but I've seen pictures. Those triangles, are they scalene, isosceles, or equilateral? You take a guess. Look at those and you tell me. Okay, they are isosceles triangles. The reason why, if the roof has the two sides on the roof, they are equal size. Okay, so the roof has two sides that are equal, and those sides are bigger than that smaller side on the bottom. So it's an isosceles triangle. The next one is this an acute, an obtuse, or a right triangle? Try it out. What do you think? Da, 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 da. It is an acute triangle because none of the angles are bigger than 90 degrees. All right, we're going to test your knowledge here, do a little bit of a recap. So we have a triangle here. Let's say that the two angles on the bottom are 40 degrees and 40 degrees, and then the top one is 100 degrees. The first question is, what is the longest side? You got to know this. What is the longest side of that guy? Okay, because that angle up top is 100 degrees and the longest side is on the bottom. Those two sides are equal because they oppose equal angles. The first question, name that triangle, is this an acute, obtuse, or a right triangle? It is obtuse. One more, is it scalene, isosceles, or equilateral triangle? It would be isosceles because we have two angles that are equal, meaning that those two sides are equal in size also. And this one here, we're now going on to right triangles. A right triangle means they have one angle that is 90 degrees exactly. And then let's say in this right triangle, that side is 4, and then the one on the left there's 3. And then the question is, what is the hypotenuse? Okay, we know the Pythagorean theorem, the good old Pythagorean theorem, that is a squared plus b squared equals c squared. So here, if we have the two sides are 3 and 4, and we want to calculate the hypotenuse, okay, so we know it's going to be a squared plus b squared equals c squared. A is 3, so it's 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, it's going to equal 25, and 25 then will equal c squared. So c is going to be the square root of 25, which is 5. So in that right triangle, we can calculate the hypotenuse of 5. We have to use that a squared plus b squared equals c squared. Just for the heck of it, I even measured it just to be sure, just so I could show you. I do recommend you measure these things so you can see exactly for yourself how it works. A few things to note in terms of full, like, integer sides. Like if there's 3, 4, 5 triangles that are right triangles, you could do a 6, 8, 10 triangle. Let's calculate that. 6, 8, 10. 6 squared is 36. 8 squared is 64, and that equals 100 squared. 100, and 36 is 6 squared. 64 is 8 squared, and 100 is 10 squared. I'm just checking our work here. 9, 12, 15. That's another right triangle combination. Now, another sort of right triangle combinations in terms of what can be integers is 5, 12, and 13. 5 squared is 25, 12 squared is 144, and 13 squared is 169. So what the heck is this? Let's see how this works in terms of a right triangle. All right, and once again, I'm going to measure this in centimeters just so you can see exactly how it works. That bottom side is going to be 12, and then this side right here, let me go up there, it's going to be 5. Okay, and then I use the protractor that is exactly 90 degrees right there. So we have one side that's 5. Let's calculate, measure it there. It's 1, 2, 3, 4, 5. And this right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, I got one. Right, it's 12. Okay, so we have the bottom is 12 and the one on the left is 5. Now we have the hypotenuse. According to the Pythagorean theorem, if we have the 5 squared plus 12 squared equals the hypotenuse squared, we did the math up there. We came up with 13. And then let's measure this to kind of see how it works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Boom. Okay, there you go. So we have here a 5, 12, 13 triangle. And again, when we do the a squared plus b squared equals c squared, it would work out. Some more issues here with right triangles. Let's say you have a right triangle where that side is 5 and that side is 5, and you want to calculate the hypotenuse. There's a kind of a quick trick here. When you have two sides that are equal, you just multiply the sides by square root of 2 and you can get the hypotenuse. So if the two sides are 5 and 5, the hypotenuse is going to be 5 square root of 2. Let's use the a squared plus b squared equals c squared to kind of show you why that's the case. A squared would be 25 and b squared would be 25, and 25 plus 25 is 50. 50 would equal c squared. C would equal the square root of 50. Let's break that down. Square root of 50 is 2 times 25. 25 is 5 times 5. So then we want to get the square root of 2 times 5 times 5. The 5s would kind of, we could cross one out and then one stays out. So it's 5 squared root of 2. I kind of did the long way of showing you that little trick. So anytime you have two sides, the hypotenuse would be the same thing, but you would multiply it by 2. A couple other things to notate. So let's say this side and this side is equal. We'll just call it x. So they're both x, so they're equal size, right? This is a right triangle, and then we have the hypotenuse. Now, just for the heck of it, what would those two angles be? Try to figure it out. What are those two angles? Little pop quiz for you. Try it out on your own. Okay, those two angles. Okay, all three angles have to equal 180. The right angle is 90. So then we have 90 degrees left between those other two angles, and they have to be equal because they are opposing sides that are equal. So they have to be equal, those two angles. And if they're 90 and if they're equal, then you divide it by 2, and that's 45. So those two angles have to be 45 degrees each. And just kind of showing you that they're opposing sides there. Did I use a protractor to prove it? That's 45 degrees. So those two angles have to be 45 degrees each. Now the next question is, if the sides are equal and let's say the hypotenuse is 10 and you want to calculate the sides, okay, try it on your own. All right, so let's do it together. Previously I said when the sides are equal, then you multiply by square root of 2 to get the hypotenuse. If you have the hypotenuse and then you know the sides are equal, instead of multiplying by square root of 2 to go backwards, you could just divide it by square root of 2. So here the x would then equal 10 divided by square root of 2. Sometimes they'll simplify that by getting rid of the square root of 2 on the bottom. So multiply by square root of 2 over square root of 2, you get 10 square root of 2 over square root of 2 squared, which is 2. Then that simplifies 5 times the square root of 2. I'm going to show you the long way, okay? Here, this is to kind of show you why that works. If you have a squared plus b squared equals c squared, so you'd have 5 square root of 2 squared plus 5 square root of 2 squared. That should equal 10 squared. What is 5 square root of 2 squared? 5 squared is 25. Square root of 2 squared is 2, and plus the same thing, 25 times 2. And that equals, that should equal 10 squared, which is 100. 25 times 2 is 50, plus 25 times 2 is 50, and equal 100, and it does equal 100, so it checks out, okay? This is the first kind of like crash course in geometry. It's a lot of information that I kind of like shoved in there for you. Keep practicing. I'm going to do some more crash courses. Subscribe to the channel and you'll get more. Again, my name is Joe Samo. This is our Math Hooligan. Keep kicking butt, okay? Keep practicing and ask me questions in the comments and I can answer them.